All right, so let's talk about the product rule today. Product rule. And if you are, by the way, looking for tutoring, um, look at this, go to this link here, calendly.com/MathSwap tutoring /tutoring consultation. Schedule your free consultation. You can also just look in the description and the link will be there. Don't forget to join my email list. Also, don't forget to subscribe to this channel for more tutorials and to like and share this video if you find it helpful. All right, here we go. So the product rule is another way to find the derivative of, well, not just a function, but the derivative of two functions that are being multiplied together. So let's actually type that stuff out. So the product rule is a way to take the derivative of two functions with the same argument. That means the same thing in the inside of the parentheses. I'll show you, that are being multiplied together. And it's very straightforward, very straightforward. Let me stretch this out so this is fully visible. So again, this is a way to take the derivative of two functions that are being multiplied together. The functions had to have the same argument for you to be able to use the product rule. All right, so this is the how you formally write it, the derivative with respect to x of f of x times g of x. And that is equal to the second times the derivative of the first plus the first times the derivative of the second. I think when I was learning this first in high school, we talked about it in the reverse order, like the first times the derivative of the second plus the second times the derivative of the first. But obviously you can see it doesn't really matter. They're being added together. All right, so let's go ahead and do an example. All right, so let's say that f of x is equal to 3 times x to the fourth minus 7, and g of x is equal to 2x cubed minus 6. And we want to find the derivative with respect to x of f of x times g of x. All right, well, good. So let us take the derivative. So remember, it's going to be the second times the derivative of the first plus the first times the derivative of the second. There's going to be the second function times the derivative of the first function. Now, remember, we're going to take, when you take the derivative of this stuff in here, we're going to take the derivative of each of these. Now, the derivative of 3x to the fourth, remember, you bring that exponent to the front, multiply it by that coefficient, and then subtract 1 for the exponent. So that's going to be 12x cubed. And remember, when you take the derivative of a constant, it is 0. The derivative of any constant is 0. Okay, so it's just going to be 12x cubed right there. All right, so that was the second times the derivative of the first. Now we're going to do plus the first times the derivative of the second. So that's derivative of these two. Again, we know this 6 is going to go to 0. Derivative of 2x cubed is going to be, bring the 3 to the front. That's going to be 3 times 2 is 6x squared. 6x squared. All right, so now let's clean this up a bit. That's going to be equal to, so I know I wrote this over here. So this is going to be multiplied by both of these inside of parentheses here. So 12x cubed times 2x cubed is going to be 24x to the sixth. That's going to be minus 72x cubed. Now let's do this right here. Plus this times the first one is going to be 18x to the sixth. Remember your the way the exponents and stuff work. We're multiplying x squared times x to the fourth. So you add those exponents. Okay, then let's do this one here. So that's going to be minus 42x squared. Now we have some like terms here. We got this, and this. So we can combine these 24. Remember, when you combine like terms, the variable and its exponent stays the same, and you just add the coefficient. So 24 plus 18 is 42. That's x to the 6th. And I like to write it in order of descending exponents. So it's going to be minus 72 x cubed minus 42 x squared. Okay. All right, good. So now let's do one that's a little bit more complicated. And by the way, remember, if you actually subscribe to my email list, you get a copy of the notes that I use whenever I make these videos, because I typically will make some notes that I use before I actually do my video. And so you can get access to those when you subscribe. All right, so let's take the derivative of 4 plus x to the 9th power times 2 minus x to the 5th power. All right, so the second times the derivative of the first. So it's going to be the second one times the derivative of the first. And remember, to take the derivative of this that has a parentheses raised to an exponent, we're going to use a chain rule. We talked about that in a recent video. So you have to use the chain rule. So that means you take the derivative of the outside times the derivative of the inside. So it's going to be times 9 times 4 plus x to the 8th power. Now we're going to multiply again times the derivative of the inside. Derivative of 4 is 0. Derivative of x to the 1st power is going to be 1. So this one is a pretty easy one. Now, so we just did the second times the derivative of the first, so we're going to do the plus the first times the derivative of the second. So that's going to be times 5, 2 minus x to the 4th power times the derivative of the inside. That's going to be 0. This is going to be a -1 because there's a negative sign outside of the x. Be careful with your negatives. All right. So this is going to be 9 times 2 minus x. I want to write this with the higher power in front. So that's going to be 4 plus x to the 8th power, 2 minus x to the 5th power. Remember this minus sign, minus 5, 4 plus x to the 9th power, 2 minus x to the 4th power. Now, one thing you could do, we'll let that be our answer here, but I want you to notice you could actually do some factoring and simplify this a little bit. It gets a little bit lengthy and nasty. You see these each have 4 plus x and then 2 minus x in common. So you can kind of factor it out and do some simplification. But for the sake of keeping this video kind of short and not having a whole lot of space here, I'm not going to really worry about that. But do it if you would like, maybe it'd be fun, good exercise. All right. Don't forget to like this video, share this video, subscribe to the YouTube channel. And if you need tutoring, holler at me. Use the link to get tutoring, okay? All right, y'all have a good one.